Hi, today I'm going to be teaching you how to use the addition principle of probability. But first, you need to know how to use mutually exclusive events and how they're relative to the addition principle. So what are mutually exclusive events? Two events A and B are mutually exclusive if A and B cannot occur at once. The events are mutually exclusive or disjoint. Either term will do. Now that you have some understanding, you can see them in the Venn diagram form. For the first example, A and B are disjoint or mutually exclusive. There's no connection between them. For the second example, A and B are conjoint. They're together and there's an intersection between them. These events are not mutually exclusive. They have something in common. Now to put this into perspective. For our first problem, there are two events. Event A and event B. In event A, you will roll a 3 on a die. In event B, you would roll a 4 on a die. The events are mutually exclusive or disjoint because of the fact that they can't occur at the same time. Using a fair die, you can't roll a 3 and a 4 at the same time. The probability of that would be impossible. For our second problem, there are two events. In event A, you randomly select a male student. Event B, you randomly select a nursing major. The events are conjoint, not mutually exclusive, because of the fact that a male student can be a nursing major and vice versa. In problem 3, event A is randomly selecting a blood donor with type O blood. Event B is randomly selecting a female blood donor. The events are conjoint because of the fact that a female can have type O blood and someone with type O blood can be a female. If you were to represent question 1 in the Venn diagram form, the two Venn diagrams would not touch each other. They'd be disjoint. For number 2 and 3, the Venn diagrams would be conjoint. There would be an intersection because of the fact that both events have something in common. Now that you understand mutually exclusive events, it's time to learn the addition rule. The addition rule states the probability that events A or B will occur is given by this formula. The probability of A or B, notice the or is underlined because of the fact that it is not and, like in the multiplication principle. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. If the events are disjoint, then the rule is simplified and expressed as the probability of A or B equals the probability of A plus the probability of B. This is quite similar to the first formula because of the fact that you have the probability of A and the probability of B. But because there's no intersection, the probability of A and B is 0, so we just won't use it. Now that you have some understanding of the addition rule, it's time to put it into perspective. You select a card from a standard deck. Find the probability that the card is a 4 or an ace. For our second problem, you roll a die. Find the probability of rolling a number less than 3 or rolling an odd number. We're finding out if the events are mutually exclusive and we're finding the probability here. This is where mutually exclusive events come into play. When selecting a card from the decks, we find that the events are mutually exclusive. There's no intersection. So we use the simplified addition rule. The probability of selecting a 4 or an ace equals the probability of a 4 plus the probability of selecting an ace, which equals 4 out of 52 plus 4 out of 52 equals 8 out of 52 equals 2/13, and is approximately 0.154. We always use approximately because of the fact that we're rounding up when we turn our fractions into decimals. For our second problem, rolling a die, the two events are conjoined. They're not mutually exclusive. Given this intersection, this forces us to use the full formula. So we'll be subtracting the probability of A and B. The probability of rolling a number less than 3 or an odd number is the probability of pulling a number less than 3 plus the probability of rolling an odd number minus the probability of a number less than 3 and an odd number, which equals 2/6 plus 3/6 minus 1/6 equals 4/6, which equals 2/3, which is approximately, very important, approximately 0.667. You've learned how to use mutually exclusive events and the addition rule.